Okay, so now we're going to go through how to calculate the expected frequency for each of the cells in the crosstab. So what I have here in the paper already is the same crosstab that I had on the slides. So this is, again, based on based on the question in the class survey asking whether you would kill someone and have no one know, or kill no one and have everyone think you did, and whether you said you were male or female. So we had 6 males saying kill someone, 13 saying kill no one, 10 females saying kill someone, 11 saying kill no one. We also have our row marginals over here, so we got 16 by adding across this row. 6 plus 10 equals 16. We got 24 by adding across this row. 13 plus 11 equals 24. And we have our column marginals down here, which we got by adding down the columns. So 6 plus 13 equals 19 to get this column marginal, and 10 plus 11 equals 21 to get this column marginal. And then 40 over here is our total number of observations, and in this case it's the number of people who answered both questions in the survey. Alright, so the thing that we want to calculate over here is the expected frequency. And we refer to the expected frequency as FE. So we have FO for observed frequency and FE for expected frequency. And to calculate the expected frequency, we're going to use this equation here. We're going to take the row marginal that corresponds to a particular cell, multiply it times the column marginal for that cell, and then divide by the total number of observations. So let me go through an example of this. We'll start with our first cell up here. So if there was no relationship between gender and how people would respond to this question, how many men in the class would we have expected to say that they would rather kill someone and have no one know? To answer this question, we're going to plug in our values here. So for each of these, we're talking about the row marginal and the column marginal for the particular cell that we're looking at. So in this case, we're looking at this cell right here. And so the row marginal that we're looking at is the row marginal for this cell, which is 16. Let's see all. So this is for male and kill. So our row marginal is 16. We also want to find the column marginal for the particular cell that we're looking at. So here we're in our male and kill cell. The column marginal is 19. So we're just going down to the bottom of this column to find our column marginal. Then we're dividing by the total number of observations, which we find here. So this is the total number of people who answered both the kill question and the gender question. So that gives us our equation. If you do this math, and this is a nice one where it actually doesn't matter which order you do it in, but if you do 16 times 19 divided by 40, you get a value of 7.6. So I'll put this in here as well. 7.6. So what this value means is that if men and women had exactly the same willingness to kill someone versus kill no one but have everyone think you did, we would expect 7.6 men in the class to have said that they were going to kill someone. So our observed frequency here is a bit less than what we'd expect. So if gender was absolutely unrelated to how people answer this question, we'd expect to see 7.6 kills for the males in the class, but we only see 6. And just as a side note here, it's totally okay to have a decimal point for these. These are just theoretical expectations, so they don't need to be whole numbers. So we're saying, though, that if, again, gender was completely unrelated to willingness to kill someone, so whether you're male or female has absolutely nothing to do with, whether you'd rather kill someone and have no one know or kill no one and have everyone think you did. If those things are completely unrelated, we would expect 7.6 men in the class to have said that they were going to kill someone and have no one know. And now we can go through the same thing for each cell to find the expected frequency for each cell in a world where there is no relationship between gender and how, you'd answer this question. So for this one, I'll just keep going down here for the male column. So this one is for male and no kill. So here, I shouldn't have circled this one because now it's going to look messy, but I'll just keep circling them. So now we're looking at, the nice thing about a chalkboard is I just scribble on everything and then I erase it, and here I have to live with my mistakes. So here we have this cell here where we're going to look for the expected frequency for males in class who would say that they would kill no one, but have everyone think they did. And so here we're going to be looking at, first, the row marginal for this cell, which is 24. So our first part of our equation is the row marginal. The second part of the equation is the column marginal. So the column marginal for the cell is just what column is it in, and then what's the marginal. And so this one is 19 again. That should make sense, because for both of these we're looking at the values for male, and we have 19 in our male column. The total is going to be the same for each of these because we have one total for the whole crosstab. So here we have 24 times 19 over 40. If you do this math out, you should get a value of 11.4. So I'll fill this in here as well. So what this says is that, again, if there's no relationship between gender and how people answer this question, we would expect 11.4 men in the class to have said that they would rather kill no one but have everyone think they did. So what you can see here is that we have slightly more of the kill no one responses than we would expect if there was no relationship between gender and, willingness to kill here. So I'll go through the rest, starting with this female kill cell. So here we have 10 observed. We want to know what we would expect if there was no relationship between gender and willingness to kill. So here we're going to look at our column marginal, which is 16, our row marginal, which is 21, plug both of those things in, and then divide by our total, which is still 40. So once you do this, you should get a value of 8.4. I'll plug that in here. So again, what this shows us is that if there was no relationship between these things, if you couldn't predict willingness to kill at all based on gender, if men and women were exactly the same in their willingness to kill someone or kill no one, we would expect to have seen 8.4 women in the class say that they would prefer to kill someone. And instead we saw 10, so we saw slightly more women than we'd expect saying that they'd rather kill someone. And just as a quick note here, you'll notice that I'm saying that there's exactly the same willingness to kill someone among men and women with these expected frequencies, but we still see different numbers. And the reason we see different numbers here is that we have different numbers of men and women in the class. So the higher number for women is just because there's more women in the class. So even if they wanted to kill somebody at the exact same rates, men kill people and women kill people at the same rate here based on this question, we'd still expect to see more observations in the cell for females because we have more females in the class. Alright, so our final one here, our expected frequency of women saying that they would kill no one. So it's going to be the same thing as we did in the last one here. I'll circle it just for the sake of completion. And we have 24 as our row marginal for this cell, so it's in the row where the marginal is 24. And we have 21 as the column marginal, so it's in the column where the marginal is 21. Divide by 40, which is still our total. And if you do this, you should get an expected frequency of 12.6. So if there was no relationship between these two variables, if men and women had the exact same responses to this question, we would expect 12.6 women in the class to have said they would prefer to kill no one but have everyone think they did. So we have slightly fewer responses here than we'd expect. Alright, so what these expected frequencies tell you, again, is how many responses you'd expect in each cell if there was no relationship between gender and responses to this question. As I said before, what we're going to be doing with the chi-square test is trying to figure out if there's a relationship between these two variables. In other words, if our observed frequencies are different enough from our expected frequencies that we can conclude that this sample crosstab came from a population where there is a relationship between the variables. So again, this hypothesis test that we're going to be doing is going to be all about the difference between our observed frequencies and our expected frequencies. And if we can conclude that our observed frequencies are different enough from our expected frequencies, we'll conclude that there's a relationship between these variables, because it's just too unlikely that we would have seen the observed frequencies that we did if there really was no relationship in the population. Alright, so I'm going to hop back to the slides there and now talk through the hypothesis test, now that we know what our expected frequencies are and we know what they mean.